I decided to create a binary game. So when the game starts, the user will get prompted with an integer starting from 1, and they have to enter the correct binary by toggling these buttons and then confirming the answer. So 1 is this binary pattern, and I get the answer correct, and it proceeds to the next integer 2 within the time frame, which is 15 seconds. So for learning outcome A, I use these 9 push buttons here, bits 0 to 7. So these are toggle the bits 0 to 7, and this is used to confirm the answer. For learning outcome B, I used interrupt-based debouncing, which can be seen in the determine state and check button functions. So if I scroll down here, determine state basically is the one that it gets run in the ISR and stores the live state of the button in a 2D array. And then the check button function is the one that checks the values in that 2D array to see if the button has been pressed or not. So if I run it, you'll see that the serial monitor down here will show the live output of the presses. So you can see that as the button gets pressed, it's never skipping a change. So it's always going from 1 to 0 or 0 to 1 and vice versa. And this uses timer 0 with an interrupt overflow period of 0.004 seconds. So for learning outcome C, I use these 2 LEDs which indicate a correct or incorrect answer. So you get the green one for correct and the red one for incorrect. And you can also use this dial here to reset the bits on the screen, and this gives you both the green and the red to indicate the reset. For learning outcome D, the potentiometer is used, which I just showed you there, which is basically to reset the bits on the screen. So if I have a bit pattern here, I can use the potentiometer to reset the bits on the screen using digital analog input. And this can be seen in the ADC setup and reset dial functions. So the user has to turn the dial all the way to the right and then back to its original position to keep playing. For learning outcome F, I use serial input to allow the user to toggle bits without having to press the buttons. So you can enter bit 0 to toggle the bit, and then you can get it correct. You can do the same for every bit in the pattern. Toggle bit 1, toggle bit 1 again, and it turns it back off, which is pretty cool. And it shows you it uses serial output to show you the live change of certain things in the program. So bit 1 was set to 1, the current bit mask is this here, and this will update every time you toggle a button or a bit. And it also changes when you use the reset dial. It will show you that it's reset. When you get the correct answer, it will give you a message like saying try again, and which is pretty cool. For learning outcome G, the LCD is used to display a start message at first. So when the game starts, enter a number in binary, and then it uses this display to show all the information such as the live binary pattern, the integer, and this timer here. So the timer is in real time and counts the seconds passed. The LCD screen is able to change in real time, and is also used to display a message when the user gets a correct or incorrect answer, which was shown at the start. So lastly, for learning outcome F, H, the timer 2 was used to use the clock on the screen that counts seconds, as timer 0 was already being used for debouncing. So this timer shows seconds on the LCD in real time, and the user has to enter the binary number within 15 seconds, otherwise the level resets and they get a message saying try again with the red LED. So you can see this is counting in real time, and if I wait 15 seconds, you'll see that a message comes up. And like before, when I get the correct answer, it will show me how long it took me to get it. In this case, 3.45 seconds.